Hello boys, Mr. Turnbull here. Today's lesson is going to be about thermal decomposition. So we're going to jump straight in with thermal decomposition and what those sort of reactions are. So in general, you've got a decomposition reaction. Okay, and just like you might, when you use the word decomposition in everyday life, it means to break something down, and that's exactly what a decomposition reaction does. In a decomposition reaction, a compound is broken down into simpler compounds or into its elements. Okay, so a decomposition reaction is when a compound is broken down into smaller compounds or into its elements. Okay, so a nice simple example of that would be hydrogen peroxide, which is what people can use to dye their hair. Okay, so hydrogen peroxide over time, that decomposes and breaks down into water and oxygen. Okay, so that would be a nice simple word equation for the reaction of hydrogen peroxide as it decomposes and produces water and oxygen. Now, if we do some formula equations for this, you've got hydrogen peroxide, which is H2O2. That breaks down into water and oxygen. Now what I'd like you guys to do, if you want to pause the video for a second, once you've jotted this down, I'd like you to work out what the formulas for water and oxygen are. We've done them before, you should know. And then what we're going to do is we're going to go through and we are going to balance this formula if we need to. Okay, so I've left a little blank there in case we need to put a number in there, but we might not, we'll see. Alright, so I'd like you to pause the video and I'd like you to complete this formula equation for this decomposition reaction. Okay, so if we go through step by step each of our stages, you've got water, which you guys should know at this stage is H2O. Okay, and we've got oxygen, which you should know by now is obviously the chemical formula O, but it hangs around as a molecule, so it'll be O2. And if we have a look and we try and balance everything, we've got two hydrogens over here and we've got two hydrogens over here. So the hydrogens in theory are done. We've got two oxygens over here, but we've got three oxygens over here. 1, 2, 3. Now remember, from balancing equations, this is going to come up in our next lesson as well. We cannot change these formulas at all, but we need the same amount of oxygens on either side. So what I'm going to do, because I've got an odd number here and an even number here, balancing it could be quite tricky. So what I'm going to do is I'm going to add a big 2 in front of the H2O2. Okay, because then what I've got is I've got two lots of all of this, so I've got two oxygens there and the two oxygens there, and it gives me 4 oxygens overall. So now I've got 4 oxygens, but I've also got 4 hydrogens, because 2 times 2 is obviously 4. So I've got 4 hydrogens and 1, 2, 3, 4 oxygens. So what I can do here, now I've got 2 on this side and 2 on this side, whereas I've got 4 of each on this side, I can put a big 2 there. Okay, give yourself a big green pen tick if you've got that one done. Alright, so that is a general decomposition reaction. Now obviously our lesson is going to be focusing on the thermal decomposition aspect. Now a thermal decomposition reaction is when a compound is broken down due to heating. Surprise, surprise. So thermal decomposition is when a compound breaks down due to heating. Okay, and that's the key thing. You apply heat to a particular compound and then it will break down into either other compounds or into its elements. And a really common example, one that they're going to ask you to look at which is what our worksheet that you're going to be doing this week is on. It's an experiment that we would have done in class, is on copper carbonate. So thermally decomposing copper carbonate. Okay, and when you thermally decompose copper carbonate, that breaks down into two components. The first one is copper oxide. Okay, and it also breaks down into carbon dioxide. Okay, copper carbonate, when heated, breaks down into copper oxide and carbon dioxide. If you want to add an extra little note as well, copper carbonate is like a green powder or a green solid. Okay, so copper carbonate is green. Copper oxide, though, in this case, is black. Okay, and carbon dioxide is obviously a colourless gas. But you guys know that because we've looked at carbon dioxide before. Alright, now we're going to do a formula equation for this reaction. Now, what's good about this one is the way the formulas work, everything is kind of balanced. Okay, it's already balanced. We don't need to change any of the numbers. So what I'm going to get you guys to do is I'm going to see if you can come up with the formula for copper carbonate, but I'm going to give you the formulas for the products, for the copper oxide and the carbon dioxide. So copper oxide is nice and simple. That is just CuO. And carbon dioxide, as you guys should already know, is CO2. Alright, so that's the formula for copper oxide, that's the formula for carbon dioxide. Like I said, the formula is already balanced, so we don't need to add any big numbers here or here or here. What I'd like you guys to do, pause the video and figure out what the formula for copper carbonate is. Okay, so hopefully you figured that out. So you've got copper there, Cu. Now it doesn't really matter what order you write the elements in. But I'm going to write the Cu here, so it's got the copper, you've got the carbon in there as well, so that's CuC, and then you've got the oxygen too, but you've got 3 oxygens in there, so it's CO3. Okay, copper carbonate. Alright, now one of the things that we did mention in one of our lessons a couple of weeks ago before we went on lockdown, which was our naming compounds. You should figure out, or you should know, that copper carbonate contains oxygen because it ends in 8. Okay, if a compound ends in 8, you know that it contains oxygen. Alright, hidden. Obviously copper oxide is obvious, it tells you, but sometimes the compounds contain lots of things but oxygen as well, and it ends in 8. That means there's oxygen in it. Might not necessarily be O2, don't worry about the O2. But it definitely means that it contains oxygen. So you've got copper carbonate there. Now we're going to introduce an extra little bit of complexity when it comes to formula equations now that you'll see as you go on through the school, and that is the states in which those compounds appear. Now we said earlier that copper carbonate is like a green powder or a green solid, so in order to show what state the chemicals in a reaction are in, we essentially write it. So what I'm going to do here is I'm going to write a little S in brackets. And what that means is you've got copper carbonate, and that is a solid. Copper oxide, we said, is a solid. So that's a little S. And carbon dioxide, we said, was a gas. So we're going to write, unsurprisingly there, a G in brackets as well. Alright, so copper carbonate, solid, thermally decomposes into copper oxide, which is solid, and carbon dioxide, which is a gas. Now, there are 2 other exceptions, 2 other states that you might need to identify on a chemical equation. The first one is obviously liquid, which unsurprisingly is an L in brackets. And then the last one is AQ in brackets. Alright, so you've got solid, liquid and gas, SLG, and you've got AQ, and that means aqueous, And what aqueous means, which is not something that's going to come up much in this unit, but it will later on down the line, aqueous means that it can be, or that it is dissolved in water. Okay, now what I'd like you guys to do now, obviously this was an experiment that we would have done in the lesson, but we can't, so I'd like you to just pause this video, and I'd like you to go and watch video link 1, because that has got a demonstration of this copper carbonate thermal decomposition reaction. So if you just want to pause the video and go and watch that. Excellent. Okay, so the last thing we're going to look at when it comes to thermal decomposition is comparing thermal decomposition reactions. So if we was to do an experiment, and one of your main activity for this week will be looking at that experiment and comparing results. If you was to compare, say, 3 different compounds, all right, copper carbonate, lead carbonate, and zinc carbonate, okay, and used to compare how much carbon dioxide was produced by each of the compounds. So this would be, say, 0.5, 1, 1.5, 2, 2.5, 3, and this was the amount of CO2. Okay, you'd plot a bar graph. Okay, I'm just making up the results and the numbers, although there is a copy of this graph in the textbook, but it's not that important in terms of the numbers. So you've got CuCO3, which is our copper carbonate. You've got ZnCO3, which is our zinc carbonate, and you've got PB, oh, I've got these the long way round, my mistake, PbCO3, and we've got ZnCO3. Alright, which of these 3 do you think is the most reactive of the 3 compounds? What do you reckon? Hopefully you've guessed correctly. It is the ZnCO3. Now the reason why that is because zinc is more reactive than lead, and lead is more reactive than copper. And what that means is that the more reactive it is, the easier it is to thermally decompose the compound. Okay, so that's the last note that I'm going to want you guys to make a note of. I haven't really got room to write it here, so it's a little bit of dictation work. The more reactive the compound, the easier it is to thermally decompose. Alright? Now, what I'd like you to do to just follow up and finish up on this lesson is I'd like you to do questions 1 and 2 on page 93 of your Activate 1 book. Okay, question 1 and 2 on page 93, and I'll tell you a little bit more about what I want you guys to do for the rest of the work this week in video 2. Bye boys.